side. Yes, so we look at chemical equations. In chemistry, you see chemical equations on a daily basis, isn't it? Everything you want to show in chemistry, you use the chemical equation to represent it. Chemical equation tells us what is happening. You understand? In shorthand form. If two things are reacting, do you see them? Mostly you don't see the reaction, you understand? Even though you can see color change or change in state or stuff like that, you understand? But you don't know what is actually happening. You don't know whether it's carbon or it's magnesium, how it is moving. But with chemical equation representation, you can easily notice what is happening, isn't it? You can easily say that these are the reactants that came together in order to form the following products. Is that clear? And that's why we say that chemical equation is a shorthand form of expressing what happens in a chemical reaction. Is that clear? It shows us what actually happens in a chemical reaction in a shorthand form. In essence, it shows us the reactants, how the reactants react to form the what? Products. Now, this is a sample chemical reaction. We have two reactants, A and B, reacting to form two products, C and what? D. Is that clear? So in every chemical equation, you have the reactant on this side, whereas the product on the other side. Is that clear? So first of all, you have to write the reactants, then you write the what? Product on the other side. Now, balancing chemical equation. How do you balance a chemical equation? Now, the law of conservation of mass says that matter or mass cannot be created or what? Nor destroyed. It can neither be created nor what? Destroyed. This ensures that the total number of a particular atom on the reactant side is always the same as the number of that particular atom on the what? Product side. If you have carbon here and you have only one carbon here, you are also expected to have only one carbon on the other side. Is that clear? We are going to demonstrate this with the following examples. I can clean up. Yes. So we are going to demonstrate this equation balance with the following examples. Example 1, hydrogen gas combines with oxygen gas to form steam. Example 1, hydrogen gas combines with oxygen gas to form what? Steam. When hydrogen and water combine, hydrogen and oxygen, you know you have H2O, isn't it? So how do you write the equation? How do you write a balanced equation for this? You have the H2 combine with O2 to give H2O. H2 combining with what? O2 to give what? Steam is water in gaseous form. This is in gaseous form, this is in gaseous form, and this is in what? Gaseous form. So that is the equation of reaction. But is it balanced? Is that equation balanced? Is it balanced? Why is it not balanced? There is two oxygen here, whereas here there is only what? One oxygen. So it's not balanced. You understand? But basically, you have to know one thing. For you to have H, you must write it as H2. You understand? Because it's a diatomic molecule. Is that clear? Most gaseous elements are diatomic molecules. Is that clear? So this one must also be written as O2. But this one can only be written as what? H2O. So how do you balance it? How do you balance it? If you put 2 here, will you be having oxygen, 2 oxygen? You are now having 2 oxygen back, and you're also having 2 oxygen here. But then hydrogen is now how many? 4. So you have to put what? 2 here. So this is a what? Balanced equation. Is that clear? Did you see the way I balanced it? What does this G stand for? Gaseous state. So write that equation, it is balanced. Now we look at the second example. Copper metal reacts with concentrated triisonitrate 5 acids to form a greenish blue solution of copper triisonitrate 5, copper 2 triisonitrate 5. Water with the evolution of blank gas, nitrogen 4 oxide. Copper metal reacts with concentrated triisonitrate 5. Example 2. Copper metal reacts with concentrated trioxo nitrate 5 acid. To form a greenish blue solution of greenish blue solution of copper 2 triisonitrate 5. Copper 2 triisonitrate 5. Water with the evolution of brown gas, nitrogen 4 oxide, with the evolution of a brown gas known as what? Nitrogen 4 oxide. Write a balanced equation for this. I can clean the up, isn't it? Yes, so this equation is telling us that copper, metallic copper, if it is metallic copper, it will be CuS, isn't it? S stands for what? Solid state, plus HNO3 plus HNO3. This is the what? Concentrated triiosonitrate 5 acid, and its acids are always in what? Aqueous state. To give what? CuNO32. CuN. Let me start from beginning to write it so that one line can contain it. I have copper plus HNO3 in aqueous state to give CuNO32, which is copper 2 triisonitrate 5, NO2, which is what? Nitrogen 4 oxide, which is a gas. Copper 2 nitrate is in aqueous state, then plus what? H2O, which is water, and is in what? Liquid state. That is the equation. Is that clear? That is the equation. So how can we balance this equation? Can we balance this equation? Copper, this S stands for what? Solid, isn't it? AQ stands for what? Aqueous. So this is gas, this is liquid. How do we balance this? Is it balanced? Copper is 1 here, so it's okay, isn't it? Hydrogen is 1 here, is 2 here, which is wrong, isn't it? N is 1 here, and is how many here? Is N is how many here? 3 back?
Yes.
No.
1.
N is 2 here. And N is here, how many? 1 back?
Yes.
So can we make N 4? Since it's 2 here already, we put 2 here. So N is now how many? 4 back? So we put 4 here, so that this one will be what? N will be 4 here too. Isn't it? Hydrogen is how many here? 4. How many is here? 2. So we can put 2 here to make it 4. Isn't it? Oxygen is 4 times 3, 12. Huh? Oxygen here is what? 6. Plus how many here? 4. 6 plus 4, 10. Plus 2 here, 12. So it's balanced. So that's the balanced chemical equation.